Welcome back, students. Today I want to be talking about converting between radians and degrees. So to firmly understand how to do this, we should first understand what we mean by radians and degrees. So here I've got a unit circle. Now when I select a specific line in there, notice how it's telling me the degrees of that. The degrees of this one is 150 degrees. Now that is a statement of this little angle created here in the middle. How wide is that angle? And that's what we're referring to when we talk about degrees. Notice I made it wider and the number for the degrees got larger. So that's the degrees. The degrees is just how wide is the angle between those two lines. Okay, now we have something else that's called radians. Now, radians is different from angles in that it is not talking about this angle here in the middle. It is talking about the length. Oops, there it goes. It is talking about the length to start from here and to go all the way around. So if that black line were a piece of string that I could straighten out and then measure, it would measure exactly pi halves. So that is what a radian is. The radian is the measure of how long the line is going along the circle. The degrees is how big that angle is. Now, certain angles match up exactly with certain radian degrees. Okay, so for instance, as we look at this chart again, if I click on this one, we notice the angle in the middle went 120 degrees, and then the line across the top represents 2 pi thirds. So 120 degrees represents the same thing on the unit circle as does a 2 pi thirds. So in our work today, we're going to be talking about how can we take an angle and then figure out what would the measure of the arc be, or in other words, if we know the angle, what are the radians? And that is what we're going to be doing for a good portion of today's notes. So we're going to take some common angles and we are going to convert them into radians. So let's just remember one thing about the unit circle to start. So here's my circle. To go all the way around the circle is 360 degrees. Now, the circumference of a circle, or in other words, the distance of that black line I just drew, the distance of it is 2 pi when we are talking about the unit circle, meaning when we are talking about a circle that has a radius of length 1. Okay, so this first question says 180 degrees is half of a circle. Now, for some of you that's obvious. If that wasn't obvious, one way we could figure it out is by taking 180 and dividing it by the full circle, or in other words, 360. 180 divided by 360 simplifies to 1/2. 180 is half of the circle. So how many radians is it? Well, if 180 degrees is half of the circle, then we must also have half the radians. So half of 2 pi is just pi. So 180 degrees is the same as pi radians. 90 degrees is a quarter of a circle, a quarter meaning 1/4. So how many radians is it? Well, if 90 degrees is 1/4 of the degrees, it's also 1/4 of the radians. Got all these pop-ups that won't stop. So 1/4 of 2 comes out to be a half. So we get pi halves. 270 is 3/4 of a circle. So 3/4. So how many radians is it? So we're going to have 3/4 of our total radians, which would be 6 pi fourths, which would then just simplify into 3 pi halves. So this is a great tool. If we know what fraction of the circle any degrees are, then we can easily use that fraction to then figure out how many radians that arc would have. So here we have 45 degrees. Now 45 degrees would be, so if that's 90 degrees going up, half of that, 45. So two ways I could figure this out. One, I can see I've now chopped this into 1, 2, 3, 4, 5, 6, 7, 8 segments that are done by 45-degree increments. Another way we could do it is like I showed up here. Just make a quick fraction. 45 out of the full circle, out of a full 360. So 45 divided by the full circle, 360 degrees, is 1/8. So 45 degrees is 1/8 of a circle. So it must be 1/8 of the total radians, which if we got 2 8s, that simplifies to 1/4. So we have pi fourths is the radians. 120 degrees is 1/3 of a circle. So therefore, if it's 1/3 of a circle, it is 1/3 of the radians. So 2 pi thirds. Now, this is going to get tricky if you ever run into certain numbers that may not turn into nice fractions, such as, I don't know, let's throw something out there. 97 out of 360. I doubt that divides well. Okay, we're not going to get a nice pretty fraction out of that. But we can still use a very similar type of thinking of being able to use some multiplication to quickly jump from one to the other. So we're going to learn an even faster rule about this of how to convert between degrees and radians. So let's start with this. Let's start with degrees. If we have some degrees, and we're going to multiply it by some number to then get our radians. So let's try this out and see if this works. And let's try it out with some numbers we already know. We know that 360 degrees should be able to convert to become 2 pi radians. So if I solve for x in this, dividing by a 360 on both sides, we end up with x is equal to a pi over 180. So what this would indicate is that we could use pi over 180 to convert from our degrees to the radians. In other words, so if we start with some number of degrees, we then multiply it by pi over 180, and it should tell us what the radians are. So let's go ahead and let's test that. Let's see if our x works. So let's take some other numbers that we already know. We figured them out from above. So let's even take that first one, that 180 should be equal to pi. So if I take my degrees, that 180 times by pi over 180 would equal pi. So yeah, it did successfully convert our degrees of 180 to then be equal to the radians of pi. All right, so that's great. We now have a number. Anytime we want to start with degrees and then go to radians, we just need to multiply by pi over 180. A similar rationale can be used to go the other way. So if I want to start with my 2 pi radians, multiply by some number to then get 360 degrees, well, that number is then going to be a 180 over a pi. So just the reciprocal of the first, which shouldn't be surprising. We're just going the opposite direction. All right, so we multiply by pi over 180 to go from radian or degrees to radians. To go from radians to degrees, we multiply by 180 over the pi. All right, so let's quickly do that with a few of these. We're going to start with 32 degrees. So that's going to be 32 multiplied, and we're starting with degrees, so that means we multiply by the pi over 180. Okay, and let's quickly simplify that fraction of 32 over 180. Okay, so 8 over 45, 8 pi over 45. And we got it. 200 degrees times by pi over 180. So that's going to give us 10 pi ninths. 140 times by pi over 180 is going to be equal to, well, 140 pi over 180. To simplify that fraction, 7 ninths. So 7 pi ninths. 920 degrees. So we've gone around the circle more than once. So pi over 180. So 920 divided by 180. 46 ninths. So 46 pi over 9. Now I hope you're seeing that once you understand it and you have this number firmly in your head, this work is fast. It is not tricky to do. You're just multiplying a whole number by a fraction and then simplifying. Okay, negative 40 degrees multiplied by pi over 180. So we're going to do a negative 40 divided by a negative 80, or 180. Oops. 40 divided by 180, get negative 2 ninths. So negative 2 pi over 9. Now, in order to go the other way, we take our radians, 7 pi over 8, and we multiply it, this time by that reciprocal, 180 over the pi. And pi over pi, that's going to eliminate, leaving us with just 7/8 times by 180. Shouldn't be too bad. So 315 halves degrees, and if you don't like leaving the degrees in a fraction format, I admit that is a little bit weird. We can go ahead and do that division, which should then give us 157.5 degrees. All right, 3 pi fourths multiplied by 180 over pi. So 3/4 times 180. We get 135. 8 pi times by 180 over pi. So essentially an 8 times a 180, since the pi's would eliminate, and we get 1,440 degrees. Okay. Next one, and it just always, it repeats. Nothing's really going to change here. So negative 12/5 times by 180. Oops. 12/5 times by 180. We get negative 432. Now notice what's happening here. There's just a 2. So as we do it this time, that pi is not going to eliminate. So I'm just going to end up with 360 over pi degrees. Okay? All right. So next thing that we want to talk about is, just as we have found the values for the 6 trigonometric functions in a previous lesson for specific degree measures. So for example, if I am doing cosine of 180 degrees, that should be a -1. We also want to be able to find those values using radian measures. Okay, so we're going to use our knowledge of the unit circle in order to do this. Now, I'm going to quickly refer back to my unit circle that I showed right here. And let's try and get that off. And now we can see our full unit circle displayed for us. So, sine of pi over 4. Now, one thing to remember as we do this, let me bring up that image. Is that we're using these numbers here. They've got an xy coordinate. Cosine will give us the x coordinate. Sine is going to give us the y coordinate. So when our problem was asking sine of pi over 4, so I look at where pi over 4th is. It's the same as a 45 degrees, and sine would be the y value, so square root 2 over 2. Cosine of 2 pi thirds. So now let's go ahead and find 2 pi thirds right there. It's the same as 120 degrees, and the cosine would be the x, so a -1/2. Tangent is the sine over the cosine. Okay, so we're going to want to put our y value over our x value. So coming back here, instead of 2 pi, so here's 2 pi. It's the same as 360 degrees. So we've got sine, which was 0, divided by cosine, which is a 1. So 0 over 1, which is just 0. All right, sine of 7 pi thirds. So our 7 pi thirds See if we can find that.